Greetings, everybody. Today we're going to look at arithmetic sequences. Use a good example here for us to look at. We were looking at alkanes, which are chemical compositions made out of carbon and hydrogen atoms. So we'll use this example to kind of review the concept here. So if you look at methane, I'll circle that there, it's created by one carbon atom and four hydrogen atoms surrounding it. And then you can make ethane like that. Notice the two carbon atoms joined together in the middle. So we're trying to find a rule here that will help us figure out the number of hydrogen atoms given the number of carbon atoms in each alkane. These are called alkanes. So here's some examples, and we've seen these in real life. We see these all the time. Here's gasoline and propane. These are made, again, out of carbon and hydrogen atoms. So how does that apply to arithmetic sequences? Okay, well, we're going to look at example here. It says, consider this sequence 4, 6, 8, 10, 12, and 14, formed by the number of hydrogen atoms in the first 6 alkanes. Now, when we look at arithmetic sequences, they're actually pretty easy. They work like linear functions. The one thing that we want to make sure we're paying attention to is the vocabulary. So when it says find A1, what it's referring to is the first term in the sequence. So in this case, A1 equals 4, and A3 equals 8. Because A3 represents the third term, A1 represents the first term in the sequence. Now it says find the differences between the second term and first term. So that's focused right here, A2 minus A1. So we can see that that's 6 minus 4, which is 2. And it says to find the differences between the third term and the second term. That's going to be 8 minus 6. And again, that's 2. And we'll notice that as we go through here, each consecutive terms, if we find the difference, A4 minus A3, of course, in this case, that's going to be 10 minus 8, which is also 2. So every time we look at the sequence, we're going to try to see if it goes up by something or down by something. In this case, it's going up by 2 every time. So that kind of acts like our slope, if you want to think about slope when we talk about the common difference. So we've defined our first term here. I should use the word first vocabulary, which is the common difference. And the common difference here, in this case, is 2. Okay, again, some of the vocabulary is what we want to make sure that we understand when we begin this unit. Again, it's not too hard once we understand the vocabulary. This little sequence down here of terms, we need to understand what this says when we see it. So just remember that n represents any term. So when we say a of n, we're just saying some term in the sequence. When we say a of n plus 1, we're saying the next term after that. Of course, a of n plus 2 is 2 terms plus a of n. We can also look backwards and say one term before a of n is a of n minus 1. Some examples of this would be like, this could be a1, a2, a3, and a4. And notice in this case, a of n would represent 2. But again, we can shift this around anywhere we like, as a of n could be any term in the sequence. Okay, let's look at this example here where it asks us to write a general expression for the common difference d. Common difference. Remember, our common difference is what we're adding and subtracting. In this case, and remember how we found that. We took 2 terms in the sequence and we subtracted. So we said 6 minus 4 equals 2. So our common difference for our alkane sequence is d equals 2. This says use general expressions to write an expression for the common difference for any sequence. So basically what we're doing is we're just going to take a of n plus 1, which is some term, and then we subtract the previous term from that to get our common difference. So an expression like that. So be comfortable kind of plugging in these general terms, a of n plus 1, etc. Okay, now that we understand some of the vocabulary, let's go ahead and write what we call an explicit formula. So an explicit formula basically looks at an expression or an equation that'll help us find any term in the sequence. Right now we know A1 for the sequence, A2, A3, etc., A4, A5, and A6. But what if we want to know A100? That might take us a while to get all the way out to 100 because we've had to add 2 every time, plus 2. And then it gets a little confusing because we have to add all these terms. So we want an equation that we can just plug in which term we're looking for and get the answer. So here's how it works. We're basically going to look at identifying the different parts. Remember we said A1 is the first term of the sequence, so it's our first term. N is any term in the sequence, and D stands for the common difference. Now this A of N, I want you to think about the A of N like a Y and the N like an X. Okay, so kind of keep that in your mind because you're used to working with Y equals mx plus B. And these sequences are pretty similar to that. There are some differences that we'll cover later, but that's basically the idea, where common difference is your slope and your A1 is your first term. Great, so let's go ahead and get started. Let's use our alkane sequence to write the explicit formula for this sequence. Again, what we're going to do is we're going to plug in A1. So we have A of N, that's our name of our sequence, like Y. Okay, so just think about that as a Y. And we're going to look at, go ahead and plug in an A1. And of course, A1 in this case is 4. So we put a 4 in that spot. And we're going to leave N alone when we write our explicit formula. The only time we plug something in for N is when we're looking for a specific term. So I want you to think about, again, think about N as your X. If you're asked to write an equation for a line, you would definitely include your X and your Y. So that's what's going on there. Okay, so we have N minus 1 times the common difference. Now in this case, the common difference we know, common difference was 2. So we're going to go ahead and plug that in. Plug a 2 there. And now we have our explicit formula for the sequence. Now one thing to note here, just in case you run into this, sometimes the sequence has been simplified. And it's just been simplified very simply with what we call the distributive property, which you've been working with for years. So let's rewrite this in case you run into this form of the equation. It's the same equation, just a different form. So notice I'm going to distribute my 2 to the N and distribute my 2 to the 1. And then I'm going to combine like terms. So I have 4 minus 2. So let's look at that carefully there. So we have a 4 and a minus 2. So of course that's going to be 4 minus 2 is 2. So our final equation here, if we have it simplified, is A of N equals 2N plus 2. And that is our explicit formula. You could write it either way. Notice the blue version or the green version. They both mean the same thing. And we've written our first explicit formula for arithmetic sequences. Okay, here's another example. Doesn't require the word problem we're just working on. It's just a general arithmetic sequence problem. It says find the indicated term. So what we're looking for here, the indicated term in this case is going to be A12. So we're looking for the 12th term of the sequence. Again, remember, we're going to start with our explicit formula. I'm going to write the general formula down again one more time. So A of N equals A1 plus N minus 1 times the common difference. Now you'll want to memorize that because you'll be using that a lot. So again, what we do is, in this case, we're given A1, so we're just going to plug that in. So we have negative 2 this time for the first term of the sequence. Okay, we're trying to find the 12th term, so we're going to plug a 12 there, and I probably should go ahead and over here instead of N. I'm going to plug my 12 in over there too. Now notice I said plug in, but really it's just a name of the term there, so we're going to leave that there. All right, then we have a minus 1 still over here in the formula, and notice our common difference in this case was 4. Okay, so notice we're just trying to find the 12th term. So over here I'm just going to leave A12. That's just the name of the term. So remember, you have to do your parentheses first according to PEMDAS. So you need to focus right in there first. So do your parentheses first. And then once we get that done, then we'll go ahead and calculate the rest of it here. So this is going to be 11 times 4. And of course that's going to be 44, and then we're going to take 2 away from that. So our final answer for the 12th term is 44 minus 2, which is 42. So our 12th term is 42. That's how we find an indicated term in an arithmetic sequence. Okay, the last example I'm going to look at with you here is what we call a recursive form instead of explicit form. So notice right here, we have what we call recursive formula. Now recursive formula looks like this box down here, except you're going to plug in 2 numbers into it. Now recursive formula, it tells our reader, if someone's reading our work, it just tells us what the first term is and then the common difference. So what we do is, again, our first term is here, A1. We've identified our common difference as going up by 2. So our common difference is 2. So in our rule, we just say A1 equals 4. And then down here we indicate the common difference by saying A of N equals the previous term, remember that's what that stands for, plus the common difference. So remember what this A of M minus 1 means? It just means previous term. So we're just telling our reader, look, take the previous term and add 4 to it. And you get the next term. So, oh, in this case, I put the wrong number there. Excuse me. I just got to the end of my video. I'm not going to redo the whole thing for that. We are going to just mark that as a 2. Notice my common difference is 2. So this is my recursive form. I'm going to box that in so it's clear. Basically, you just look at it and say, oh yeah, there's a1, it's 4, and there's our common difference. Recursive formula. Now this formula does not give us any term anywhere that we like the explicit formula. That's the meaning of explicit. It tells you specifically a term given an n number. Okay, so that concludes our first video on arithmetic sequences. Hopefully that helped you. Have a great day.